Hi, Srikanth. We'll start the session.
Sure, Kavya.
Okay. So, good morning, everyone. It's been a while since we all connected, and this is the last session for this financial year. And Srikanth has been kind enough to join us for another session. Some of you might have joined for our previous sessions on cloud in this series. So after we have completed the major topics surrounding cloud, we thought we will have one session especially only for applications. So today, Srikanth will be showing you three case studies wherein cloud architecture has been used. For people who are joining for the first time, Srikanth is from IDP. He is head of technology for IDP, and he has an experience of over 20 years, and he specializes in cloud solutions and architecture. So over to you, Srikanth, if you would like to add something, and then you can start the session.
Thanks, Kavya. Nice to be here again. I think majority of you probably would have been on the previous sessions, as Kavya just said. I think we spoke about the cloud from an infrastructure perspective. We spoke about different types of cloud implementations, like the containers to serverless, etc. And also we spoke about different types of architecture in the past in the other sessions, like the microservices architecture, event-driven architecture. We spoke about edge computing. We touched based on the Internet of Things and the applications around it, and what is possible to come into the future, right? We spoke a little bit on some of the evolving concepts of tiny ML in those edge computing concepts. This session is more focused on what's the value the organizations who has implemented the solutions on the cloud has got. When we talk about the value, it is about the customers, it's about the customer experiences, obviously, converting all of that into a revenue stream for these organizations who has adopted cloud. We picked up three use cases, and they are kind of brands that you would already know, and the organizations that you would know, very popular. So we'll get on to the first use case, and a case study is Spotify. Uh, I don't know how much we could be interactive here, how much you can start typing it in the chat. Uh, I'm pretty sure majority of you who are here would be using Spotify for listening to music or podcast, any of that sort, or you yourself could be an artist on Spotify also. I'm guessing there will be some other artists here. How did they manage to get onto the cloud? How did they get value out from the cloud? Talking about it, let's look at where they started. This is Spotify's journey. They were a startup, and when you are a startup, you can't have heavy investment. So they started very basic with, when we say about bare metal servers here, it's largely an on-prem, could be a data center, locally hosted data center, or something available within their region. And they were largely running monolithic PHP and Python applications. And it grew in popularity, and there are many users who started leveraging the platform, and they started getting the bottlenecks in terms of their implementations of how they leverage the traditional data centers and their SQL databases that couldn't scale up. Uh, Obviously, what is the impact? They couldn't have a good sort of successful releases. Their quarterly releases were a bit of anxiety. That means you don't know when what will go wrong, and there were many service disruptions. The users were not very happy. The recommendation engine is what is at the core today. If you're using Spotify, you know how the recommendation engine is working so seamlessly, and it automatically recognizes what your likes are, and then the playlist is automatically adjusted. If you wanted to give control to the recommendation engine of Spotify, it takes control of and gives you the right recommendation of the next song, which the genre that you would be interested in, right? And you like to hear, or the podcast that you are interested in, the subjects and the areas that you wanted to hear more. Whereas what used to happen earlier, it was all relying on batch processing that runs every 24 hours. That means imagine you listen to a song today, similar song would be played tomorrow for you. That is how bad it used to be. So that is where they realized, and this is from their engineering director, that it is their infrastructure that was holding back their ambition. Their ambition was to deliver things that you see today, because it's not just about the product itself. Spotify, in fact, has evolved into the practices also. Practices, I mean, the software delivery models. So there is a Spotify model itself, how you structure your teams, how you deliver your software itself. There are inspirations taken from Spotify, similar to Netflix in that case, right? They have built their own ways of doing and delivering products and services. Many other organizations, including ours, right? We take inspiration from these organizations to build our teams. And this is where their engineering director's comment was around not able to innovate, right, at the speed of what they were imagining. And underlying the main concern, they had the good team and all of that, but it's the infrastructure that was holding them. So what did they do about it? They started with first with a migration approach. They looked into multiple cloud vendors, obviously, and however, whatever the decision process they had got, they chose Google Cloud Platform, GCP. And when it comes to architecture, as I was saying earlier, we spoke about microservices, the advantage and the pros and the cons as well, and considerations you need to have for microservices. This organization, Spotify, has decomposed their monolith, which we said, right, is on a PHP-based monolithic application into around 1,600 microservices that run today. And their whole recommendation engine was rebuilt on an event-driven architecture using PubSub. If someone who has not been in the previous sessions, event-driven architecture is where things happens, respond to when an event happens. So an event could be an subscriber or an user listening to a song or listen to a song. There is an event generated. There is a button click, there is an event generated. You land onto a page, there are events generated. So this is how behavioral analytics and all are built. Recommendation engines are also built in a similar way. There are algorithms that run by capturing all of these signals. So they have rebuilt their whole recommendation engine using event driven architecture, and they changed their deployment strategy. They started doing containerization with Kubernetes. We spoke about Kubernetes containerization in the previous session. So they got almost like 13,000 containers that could be scaled independently. So every service, whatever the best sizing they could do for a service, like if you take Amazon or Spotify, they all have got microservices, and each service is put into a container. And the boundaries of what is the bounded context of each microservice will be determined by those respective teams, but they will try to keep it as much as the basic principle of a microservice does one function, right? One thing. So if it is responsible to uh, provide service for payments, it does payments services alone. If one is for an cart management, it does only cart management. So likewise, they have got like around 13,000 containers that are holding these 1,600 microservices, and they are all scalable services. And what happened, right? Business impact, this is where it comes, right? How much ever you invest, it has to be converted back into a business impact and value. And what happened thereafter is that features that once required weeks of coordination to deploy one feature now got deployed in hours. So that, which is converted into like a 91% improvement, that accelerated their innovation. So now look at their roadmap. They wanted to deliver their features. Now they can run with such a fast pace that they can deliver to the end users. If there are feedbacks coming in, we know how they brought the agility for their business. So it is the engineering teams, the technology teams that made it possible for their business to grow faster. Velocity, how the teams can run faster, do deployments. Now they are able to autonomously deploy over 200 releases daily, which is like not possible in for many organizations. Yeah, including ours. We kind of uh, get to a point where we'll have to schedule some of them daily or weekly basis as well. But organizations like Spotify has solved that problem for their teams. They can run so fast, and compared to what they used to do, like one or two releases earlier to a 200 releases per day is like the game changer for them. The event-driven recommendation system process is actually now processing 100 billion events daily. Uh, and if you are a Spotify user, I'm a Spotify user, we all go onto a homepage, there are events generated. You go and click one of the playlist, there is an event generated. You play a song, there are events generated. So likewise, there are like 100 billion events that are being processed. And all of this is possible because of their cloud adoption, which was a limitation back when they were on a monolithic architecture on on-prem on just the bare metal servers earlier. And ultimately, what began as a technical transformation ultimately became their competitive edge in the streaming marketplace, where you have got many players in that, but you can recognize Spotify being the leader in that space without any doubt. Okay, if you have got any questions, please drop it into the chat. We can pick it up after we go through the other two use cases as well. Now I'll move on to the next one because we're talking about talking to you guys. We are into the education, edutech, and you guys are into education as well. Uh, why not take a good case study of an education provider or a course provider, Coursera, and how they have revolutionized the global education through their cloud adoption. Again, on a similar lines of how what we spoke about Spotify, uh, what is the mission for Coursera? Very simple and probably noble because it talks about education, is to provide that universal access to world-class learning and cannot be constrained by infrastructure. And of course, that is what was limiting them. But their core mission was to provide that world-class learning across. And I think we also have a few other platforms in this space, but we picked up Coursera, which has got a good success story here to talk about. Again, same problem and talk to their CTO. It is obviously their servers in Virginia, for example, were having issues when someone in Vietnam wants to access, right? But it was ultimately their technology that was becoming the bottleneck to achieve their mission to provide that universal access to the world-class learning. On similar lines, their platform began as a monolithic Python application. And just look into this theme that you can see here. There is not just the infrastructure change alone that has made the whole difference. It is also the architectural choices when you're actually adopting to the cloud. Because the value you get is not just by moving from one server on an on-prem onto another server on the cloud. And this is exactly the benefit we see at IDP as well. Initially, your migration might be a lift and shift. You built an application. This is what these organizations would have also done. Not all of them would be refactored on a single day, which is not a good approach either. So you look at identifying the core services when you have built something like this vast. You wanted to modernize some of the services that are very critical, and then slowly and have a plan to modernize all of your other applications into the new state of architecture or modern architecture. uh, when we talk about microservices, there is also concept of modular monolithic as well. Not necessarily always it has to be microservices, but then you know what's the benefit you're going to get from this. You're converting your monolith into microservices and looking at adopting to serverless where possible, because that gives you the ability to scale. Because look at these organizations, right? They're not service organizations that have to invest heavily on someone to manage their infrastructure. So they look at including IDP. I keep using IDP's reference because including IDP, we don't want to invest heavily on for us on people to manage our infrastructure. So that means we don't want the data centers to be there, or even if it is on the cloud, we don't want patching of servers on the cloud to be taken care by us, right? So we want most of these to be managed services. This is where we spoke about serverless concepts earlier. Serverless uh, functions or the components that these cloud providers offer or pay as you go services. So that means the whole responsibility of managing those servers, the patching of the servers, anything in the background is all the responsibility of the cloud provider, whereas we only just consume and pay as what we use it for. If you and the billing has been so transparent these days that you even get millisecond billing for serverless components. So that's the advantage we get from the cloud, and this is what is happening has happened at Coursera as well. So they started getting a surge in the terms of the peak volumes of the students getting enrolled into millions, and of course this is quite popular across the globe. Their architecture and the infrastructure is what started breaking, and that's becoming bottleneck concerning them how they scale up their overall business. If you look at some of the assessment grading used to take almost 30 minutes during those exam periods, which is not a good user experience. Of course, once you start experiencing something like that and current world, you will have an user drop rate, right? And that is where their transformation journey has begun. Again, they chose Google Cloud Platform. This case, they decompose their monolithic application into 140 microservices. And these are not small numbers, right? Considering what we experience generally, there are quite a lot of services. There are organizations like we spoke about 1,600 in Spotify. There are, like, if you've been using Flipkart, they have got close to 6,000 microservices. Uh, yeah, there are organizations like Netflix runs into few thousands as well. Uh, Many of them have got a lot of microservices, but this is possible at that scale only on the cloud. Video delivery system has moved to a serverless architecture we spoke earlier, and that means automatically scaling with regional learning patterns around the globe, because you need a bit of localization while they are global content. You need some bit of localization and understand the patterns of the learners of the platform and start adopting to that and deliver content accordingly. uh, Similar deployment strategy, they use containers. Again, business impact, infrastructure cost decreased by 4.2 million, right, in spite of the student enrollment that has grown to 140%. The velocity, you can see that 12 million concurrent learners during the exam periods, global exam periods, without any performance degradation. So if you, sorry, if you have any questions, you can post it in the chat. Again, it's a similar success story that is a technical monetization. Just give me a second. I just have some water. Sorry, I just had to add some water.
No problem, Srikanth. Hope you're okay.
Yeah, I'm okay. Can you still see my screen?
Yes, yes.
Okay. Yeah, that's on the Coursera. Um, yeah, if you have got questions, please keep posting it on the
Shrikant, if you
chat.
can add how this velocity is handled, is there something from the cloud side that helps in the velocity handling for both cases? Because millions of users are using concurrently, right?
Mhm.
So, how does it work?
Yeah, so it is about the selection and the choice of the architecture and the cloud components that you choose. So, like take an front end a website where you interact with, right? The first interaction that happens. Largely, it is content based. So that means we use content delivery network. So if you take on uh, AWS or Google Cloud Platform, you have got CDNs available. So you replicate the content to the local regions. So that is where the edge. So the CDNs are at the edge. So if you are accessing it from Coimbatore or Salem or Chennai, it will find the closest edge location to deliver the content for you. That means the static assets that are there are replicated across the globe. So that's where you get anonymous user journeys to have the content first available for them. But when you then look at as a logged in user, once you register and then you wanted to go through a course or you want to listen to your music, right, where there is possibility of caching available, they would be cached, but certain things has to be, certain interaction has to be dynamic, like video content. Some of these are, they're not changing, right, as per the user requirement, because they are recorded videos, or for example they could be replicated across regions. So that's how you get the scale, right, how you could scale it for the volumes that you are having, like this 12 million concurrent learners, right? And that's about how the streaming solutions have been put into place. Of course, the users' internet bandwidth also matters, but it cannot be the infrastructure that is hosting the content would be the bottleneck. And then when it comes to some of the dynamic content, so the microservices are largely organizations keep it in a particular closest location to their user base. So if your users are in and around Asia, right, for example, you might choose to keep it in Singapore. Or if your users largely are India based, you could choose it to be within India, like you have got GCPs or AWSs in Mumbai, Hyderabad kind of regions, right? You could keep it closer to your services, closer to those regions. So one, you gain the latency issue. You have got better closest proximity to the their data centers. And then the second one is about the access from an privacy perspective as well, as you would be covered if you wanted to keep it within a country also. But yeah, from a scaling of volumes, velocity, and business impact, the scaling is all about your technical choices of leveraging content delivery network, CDNs, caching solutions, and of course, when it comes to the backend services, high performing databases, that's where largely the contention generally happens. So having a right choices of databases is also very important. And we spoke about serverless. That's the advantage and the beauty of with serverless, because they can uh, scale to internet level how much ever you wanted it to be, because you're going to pay how much ever you're going to use it for. So you don't have to, unlike in a traditional way where you have to buy more servers. Even in the cloud, if you go for an elastic cloud compute, you could auto scale some of those missions, but then still it is like the whole mission you are going to pay for, not that one function within that mission. So the mission, you can't just have a mission for one function. You will anyways have multiple services holding in that one, but you will start paying it for when there is no demand or traffic as well. Whereas with serverless, you get that advantage. Hope that answers Kavya your question. And if that was a
Yes.
similar question
Yeah.
for others.
Yeah.
So we'll move on to the last use case, because we're talking here in India. Probably I thought we'll bring in a local organization or an India-based organization, Reliance Jio. You know how popular they have become, where they got like billions of interactions that happens every day through their telephone network, and what has enabled them through their cloud innovation. Again, so similar storyline. They they weren't just building a telecom network; they were actually building a digital infrastructure. And this is the Reliance story, and this is the Reliance Jio story as well. Uh, a traditional telecom architecture will not scale, and they know it very well. And but they have to start somewhere, right? And where they started, their infrastructure was uh, largely of traditional telecom systems. The proprietary hardware, very specific vendor locked in hardware they had. Again, they have acquired some organizations probably where they have got monolithic applications, and the customer data is spread across regional data centers. So this is Chennai data, this is Mumbai data, kind of. They had a lot of segregation of customer data. And the worst part is when it comes to user experience, they had service activation that used to take more than 24 hours. And this is, I don't think so, we all have any patience to wait for that long for an, if you take a SIM card and you wanted to start talking immediately, right? If it takes 24 hours, then obviously it's not the right choice. And their billing systems were operating on an overnight batched process. Uh, their earlier initiatives that they had were basically, again, patchwork of their complex systems, and Oracle database for billing, IBM mainframes for customer management, and every custom application being built for the service of offerings. Every of these services started reaching a breakpoint when they started getting more and more subscribers onto the platform. In this case, it is a hybrid approach of what Geo has taken. So they got an AWS migration story, as well as they have got their own Geo cloud infrastructure. At some point, they might compete, but currently it's like that hybrid. It's not Geo cloud infrastructure available for the public, unlike AWS, but they have gotten a hybrid setup done. They decompose their telecom systems into 300 plus microservices. Again, real-time activation services have been deployed using event-driven architecture, and they were processing around 30 billion transactions as on today, right? Their customer data platform that unified, because we spoke, they had very siloed customer data spread across digital regional data centers. They have adopted that serverless approach using Lambdas, which is a serverless compute function, which is the smallest compute unit that you can get to run your business function, which has got that auto scaling. We spoke for the earlier question from Kavya, we spoke about having serverless components, how it can scale. This is what they leveraged it for. Again, from a deployment perspective, they were using Dockers and Kubernetes for orchestration, and they have got deployment across the country. So they have got multiple presence in the country, including localized edge centers, data centers, and they kind of revolutionized the telecommunications in India. And so the infrastructure cost reduced by almost $430 million. And irrespective of, they have got close to 500 million users now. All of this, I think we spoke in the other two case studies, has dramatically increased their team's velocity. They were able to deploy new features almost 180 times is what the statistics says weekly, compared to what their monthly releases used to be previously. Again, this is one of your India's largest digital transformation initiative, where you have got the scale of users that you can see, almost like 500 million users. who are previously not onto the technology earlier, right? I think so why we'll call it Geo, consider it to be that Reliance story as well, right? As when we knew from 2003 period of time. So with that, we kind of like come to the closure of all the three different use cases or the case studies that we had. Happy to take any questions. Are there anything in the chat?
No, nothing right now. If there are any questions, they don't have to be necessarily restricted to the use cases that Srikanth has projected today. You can ask regarding that, as well as you can ask anything in general regarding cloud, which is his primary expertise, but anything in general in technology also, I'm sure Srikanth can answer.
Yeah, sure. Happy to do as much as I could, right? At least shoot the questions, no?
So, Srikanth, are there any use cases that you think there are other technologies that are more suitable for optimization instead of cloud?
Any specific use case or
Yeah, any examples that, how do you choose which technology works best, especially for optimization?
from a cost perspective, or is it sorry, I'm not
In
getting your
general,
question.
cost, efficiency, anything else? What are the considerations that would go into choosing the technology?
So when it comes to your technology platform, like yeah, if you wanted to look at where should your applications be hosted, right? Where should you start doing your innovation? So it's about the organizations and their choices and what regulations they are has to bind to. Take banking. Banking has come onto the cloud, which usually was not the pattern earlier. They have a lot of regulations, right? Insurance, health industry, they all started moving on to the cloud, and they're getting very specific services as well made available on the cloud. They could start leveraging. So this is where the difference between if you're a product company, it is the innovation that you talk about. It's the product innovation compared to investing your time on managing infrastructure. So traditionally, or many organizations still probably are struggling with managing infrastructure. They have to have heavy investment and upfront investment and cannot scale. If like take those case studies were exactly like that, right? And many organizations are still in that, probably in that s- uh, the world where Spotify or Geo or Coursera were there earlier. So why we're talking about cloud is look at where you get the cost benefit analysis done, and the advantage you get is you could start doing prototyping. You can fail faster and you can fail cheaper uh, in the current setup that you have got. Just getting an website up or getting an app, or in these days we're talking about conversational chatbots, AI chatbots, all of these are possible very quickly on the cloud. Whereas for you to set it up all by yourself would cost you into a few, at least few thousands of dollars, right? Which you can avoid. A very quick prototyping to put up a bot hardly takes 10 to 15 minutes, right? And including you get prompts to do it also. So all of these are possible. And now you can have got a lot of SaaS providers available on the internet. If you want to go, if you want to do a product management, you want ideas about a product, you want to create images, you want to create videos, right? All of these services are on the internet available, and that's all possible because of the offerings that they take advantage from the cloud. So definitely there is an business value. But yeah, again, it's industry to industry, what limitations they would have, what regulations they have got. Country-wise limitations has to be, and regulation has to be considered. Privacy is being one of the core at it, right? GDPR in European, every Asian country, including India's DPDP Act, right? All of these has to be considered where you put your data. If that cloud provider is compliant enough, and what are your security requirements? Is that security requirements provided by the cloud good enough for you? All these are the considerations.
Shrikant, there's a question on how students can, experiment. Are there any platforms available through which they can experiment on using cloud tech?
Yeah, so all of the cloud providers has got, you can go sign up with AWS, for example, as an individual. You get a free tier. There are majority of the services has got a free tier. You can experiment with that. Beyond that point is where there is billing, and you have control of your billing as well. I'll take AWS as an example. You can set alerts, you can set budgets, you can say I don't want to cross beyond this point, and you get. And also, I think AWS offers a lot of credits. If you participate in certain events, you get credits from AWS. So you can leverage that credits. It's almost equivalent to dollars for you, right? Or rupees, so that you can convert. But majority of the services, there are free tiers available. If you're experimenting, it's like a sandbox for you. Create your own account, get onto AWS website, go create your own account. You can start exploring almost all the services. It's like your production account only. You have almost all the services available, whichever, if your interest is on AI, ML, you have got services like Amazon Q for business. You have got Bedrock. So if you are interested on uh, the LLMs, the foundational LLMs that are available, almost all the foundational LLMs are available. Depends on individuals at their expertise level. If you wanted to leverage those models, that is available as well. And there are also other, because if this question is on the cloud, I think, yeah, I would encourage if you want to get onto AWS. Similar thing is available with Azure, uh, Google Cloud platform as well. I can drop the link here.
Yeah, that would be very useful. Also, Shrikant, I just saw somebody had attended an AWS event just a day or two before. There are a lot of events that they do conduct, and there are a lot of certifications that they offer also. So, what do you recommend for students or anybody in the academic, sector? There are too many options. What do you think is of more value
So
from the
there
industry
is an
point of view?
yeah. So there is a learning path that you can define for, and there are preset learning paths as well. So start with an foundational course, which is called in AWS. It is called Essentials, and a practitioner, cloud practitioner. That's where it starts with. So you start with a cloud practitioner, and then to get the breadth of the services details, you do an associate solution architect certification. Cloud practitioner is free of cost. Associate solution architect would cost you. Uh, and then thereafter, you can choose different paths depending upon your interest. There are paths for security. There is path for DevOps. There is path for professional solution architecture. There are developer paths. So, and there are also, if you go into skill builder, I'm not sure how many of you would have explored skill builder. I'll just push that link as well. Just give me a second. So the first link is for you can sign up for AWS account, and then you can also sign up using that same account. You can get onto skill builder from AWS. I posted the second link as well here. You can create a free account. Majority, there are many courses offerings on skill builder that are free of cost. There might be some which has to be paid. So you can make a choice. If you're still in academy, if you're still in learning path, there are many courses, including AIML practitioner courses, right? Or certain badges that you can obtain from skill builder. Very good if you are focusing on AWS.
Okay, thank you. Thank you for sharing the links, Srikanth. Also, one other question is there. During some many unexpected events like outages or this is on the technology or any cyber attacks, how does cloud help in the business continuity?
Okay, so when it comes to cloud, there's always a shared responsibility. Cloud and security perspective. Security is a shared responsibility. So what is on the cloud and what is in the cloud was right. That is where AWS or any cloud provider will ensure that their infrastructure is protected, but you are responsible for what you deploy it onto the cloud. So if your application has got vulnerabilities, obviously you will be under attack. And then there are components. So when we talk about the defense mechanism, so you need to understand because see that's a big vast subject by itself, right? Um, an attacker would have different motivation levels. So depending upon their motivational levels, the type of attack would be determined. So these malicious users, uh, sometimes you get so you talk about denial of service as a DDoS, right? A denial of service and a distributed denial of service. So if you take these cloud providers, provide you firewalls. And you get like, for example, an AWS WAF is an managed firewall that protects you from an DDoS attack. So that means it can stop if there are patterns that it can identify that it has an DDoS. But what are those patterns? You can review that in their documentation. And they also have got machine learning algorithms deployed. It is where you have got a distributed large volumes of requests coming in from an IP or from an user or things like that is what they will protect your service from. Because ultimately the impact for your business is a genuine user not able to get access to the services is where your business impact is. So someone is actually overwhelming your services with those large number of malicious requests coming in. So you need to have a disaster recovery plan when you want to talk about a business continuity. You need to have a disaster recovery. And there are different BCP, business continuity plans, and the factors of why you are into an BCP. So a BCP could be of an unexpected event, right? That could be from an a political situation, or it could be a calamity, natural calamity issue, or it could be some of these kind of an attack. So take for example a ransomware. What happens with a ransomware? So the malicious user would have already got access to your systems, your data, and now the possibility of getting that is only by heavy cost that you have to spend in terms of paying that user or that malicious actor and then getting your services back, which generally is not the way that organizations wants to do. So because the amounts that you'll have to pay is almost like you'll go bankrupt, right? So the disaster recovery plan is very important for the organizations to have, where you can come out from that situation where you had your backups, where you can spin up your services again. This is where the advantage you can take from the cloud is you are in a particular region, you can spin up a new account. Like if the link that I posted, right? As soon as you go there, you know how easier it is to get an account. For an enterprises, it's much faster because spinning up an account and then putting all of our microservices and the applications onto that is faster. But the challenge would come in terms of the data, right? The data that was in flight. So we would have already compromised on some of the data that we had, but not talking about what protocols or the measures that we put in place earlier in terms of the encryptions and the how the data is protected. But we would have some recovery point. So that is where the we talk about an recovery time objective and then recovery point objective uh, that we agree with business to say this is how long it would take for us to get the services up back, a recovery time objective and a recovery point objective. This is how much of data we can potentially lose while we do that recovery. So these are the considerations of having a DR plan, and you need to exercise this DR plan depending upon your risk profile, whether you do it once in 6 months or once in a year, and then you report it back. Every organization, enterprises does this, and they look at their critical applications. They run the DR exercise, like how we do an fire drill, right? We might not have the fire, but if you are living in large buildings and things like that, there will be fire drill. You have to do the evacuation and all. It is similar exercise we go through with an DR exercise and a disaster recovery exercise, where to check whether we have got all whether the situation is in control, how long is it taking for us, what optimizations we should do, whether it is like on the cloud or on-prem, it's almost the same, but your recovery time would be much, much faster when you're talking about on the cloud. Hope that answers.
Yes, Srikanth. There's one question on the chat box regarding the some issue about AWS account.
Mhm.
If you have some experience on it, you can share.
Okay, so if you're not seeing it in the console and it's still running in the background, I'm surprised it might not be the case. But what you could do, Dhanlakshmi, is log a support request with AWS, and you can tell them that this is more of a student educational purposes that you're using, and they will in fact waive off. I'm not promising on behalf of AWS, but they potentially can waive off any bills that has been generated. But you need to justify what has been done, and they will go also look into the logs, right? If it is just the process that is running and there's no activity beyond that, you might not get charged. See, this is where, right? If you are playing around with EC2s, yeah, you need to be very careful, because some services are instance-based services. So instance-based services are charged like your databases, your EC2s in AWS. You go and ask for a certain configuration or an emission size, and you will get billed for it for whatever the tier that you are in. This is where if you wanted to get around into serverless components, start looking at how you could deploy something similar in an Lambda, for example. The same code, what you've written in EC2, in an application in EC2, see if you want to convert that into a Lambda function. Then it's only on invocation. Only when you call that function is when you will be billed. And that billing is also in milliseconds. And I don't think so you would ever cross the free tier in it. Not saying you'll not, but if you're only using it for educational purposes and some prototyping, I don't think so you would cross the number of invocations you get in a free tier per year. But yeah, better log it with their support. You'll get response at least within 24 hours.
Sorry, I don't see any other questions. If there are any other questions, please feel free to drop the questions, or you can raise your hand since the session is over. You can feel free to also directly talk to Srikanth. We'll just take a couple of minutes, and if there are no other questions, we will wrap this session. Also, Shrikant, are there any cases in from your experience that you have seen wherein there were some obstacles in, using cloud, or that was not suitable, or some kind of failures that you have faced during uh, implementation of cloud tech?
Yeah, of course. Yeah. So if you take my experience at IDP, right? So we started our cloud journey in 2019. Um, earlier to that, of course, we can say that we were on the cloud, but that was largely for hosting, right? So we had an application, we put it into an where it was on-prem, we put it into an EC2 in a box and then run it. That's all was our earlier implementations were on the cloud. But then when it came to us start leveraging AWS in this case as an innovation platform, that means we wanted to build our mobile applications. We wanted to build our integrations on the cloud, taking away some of the middlewares that we previously had. Heavy middlewares, right? That we used to spend whole lot of money and effort in building and maintaining them. The challenges were, I think, in terms of how we adopted, we made a big leap in terms of from where we were to where we jumped into. Of course, not all organizations wanted to take that level of risk from going uh, with some of these proprietary services onto cloud using serverless directly. So that's where we face challenges in terms of how these components, because they're all multiple small components that you need to choose in a right way and then orchestrate them. Like take a one example of a building and microservice. Our teams didn't had experience building microservices, so we had to get someone who's had experience in doing these deployments first. So infrastructure, you could go into the console, like some of these team members or some of these users here has got console access. Go click this, click this, click this, and then you get a service. Click this, and then you deploy something. Uh, but that's not efficient, right? We need to learn how to codify that, how to efficiently deploy it. So the velocity will come when you start doing infrastructure as a code. So we need to bring in some experience in that, then start training people in it. There is a different understanding. The security, you spoke about security, and there was a question around security as well, right? What are the guardrails we need to put? What controls, security controls we need to put to ensure that we are not, because obviously everyone will have that fear factor, right? Once you put into cloud, like where is it? What is going to happen to my application, my data, right? What controls you need to put? So these are all learnings and standards that we had to start doing, and there were lessons learned over a period of time, because when you're not comfortable, you also start doing not comfortable, but enterprises will also force you to do pen testing, penetration testing. So penetration testing will expose if there are any vulnerabilities, right? Once you know what those penetration testing results are, then you wanted to go and fix. And in the from all of these learnings, how we matured is we have got developer environments that are got plugins that can detect any vulnerabilities in their code level, and any vulnerabilities that is there at the infrastructure level, that what they are building. And then when they move it on to, and I think most of you would know about CI/CD, the pipelines. When they start building it onto the pipeline, there are again checks done. Uh, and once you deploy, there are guardrails. When we say about the guardrails, they are the ones that protect us from something mishap happening, right? So those guardrails will be checked. For example, if I have got um, a bucket, S3 bucket, for example, right? An S3 bucket will always have to be private. It can be only public if you're only hosting a website, for example. If I'm storing customer documents, I wanted it to be private. So I think these days AWS has got an inbuilt mechanism. By default, it is private. You have to go make it public, but you can also catch them and have that recorded during the deployment to say, oh, if you're deploying something which is S3 bucket, which is public, are you sure you wanted to do that way? Because I can see it is not intended for an website. So I think that's where you get to start leveraging the uh, cloud in terms of making sure your applications are also protected. So largely from our experience, it is a journey, right? But depends on the organizations, how much they want to invest. Bring in the right investment in terms of your application architecture, application engineering, your cyber security, and then observability is one of the important thing. You need to constantly keep observing your applications and the traffic that is coming on for you to be more predictive and proactive than just being reactive to after something happens. You can start predicting something would go wrong. It's not always about the security alone. It could be some components not functioning well. So you could try to find those with the observability. So these are the topics that we could pick and talk about in the next sessions as well, Kavya.
Sure, Shrikant. There are two other questions. Would there be any useful resources for AWS infra architectures like pictures and layouts that can be used for students' practice? Jeevan Kumar has asked this question.
Yeah, I think there are many out in the internet, but if you have got, because it all depends on the use case, Jeevan. So it depends on whether you want to deploy a web application or a mobile application, or is it an AI based application, so or a chatbot. So there are resources and patterns available on the internet itself. But yeah, if you got very very specific use case, I can also share what is available very specific to that. But I can share some links maybe. So can I share that with you, Kavya, which you can
Sure, sure. I can
share it
share
with
it.
the team?
Yeah, yeah,
Okay,
I
yeah.
can share it.
I'll try to source some more, Jeevan, and share it with you.
Thank you for that, Shrikant. And another question from Shobana. May I please know if there will be velocity variations in different scenarios?
So your velocity question is around for the people and the speed at what we are innovating. That's my assumption. That's where the question is. Uh, of course, and what we took are all the success stories and their journey, and it's not always that happy green lights everywhere, right? And for every organization, and within each organization, there will be different teams which will have different velocities. So in the cases of how long it took for each of these organizations to come from their state A to state where they are now, it's not all same, right? The time that it took for them for the transformations is varying. We only spoke about what is the transformation, but not about and when it happened, how the velocity has changed from the previous state to the current state. But each of them has got, of course, they're not all same. Uh, Investment on people skills and is where I think it would vary, and there will be also depends on the type of organization. The organizations that are startups versus enterprises, startups will be much faster. Enterprises with a lot of process and their own protocols and things to go through, things might appear to be slower in terms of getting the velocity benefits. Hope that answers, Shobha.
Think, yeah, that's all the questions there are, and I think we have also reached the time limit. If there are any other questions, I feel free to share it with me on the email. I will share it with Shrikant and we can get them answered as well. And also the resources that Shrikant will share with me, I'll share with everyone on the emails that we have from the registration for this session. So hope that will be useful to you all. Thank you once again to Shrikant for taking another hour of your time to share with us and to having put up this very nice presentation with excellent use cases that I think people can, uh, reflect with. And thanks everyone again for also joining us for this session. So we will come back in the next financial year with something else also in addition to what we are already doing. We'll keep you posted. Thank you all for your support throughout this year. We have completed actually 10 sessions in 12 months, so that's a huge number. We have been doing at least one session almost every month, so that has been great. Thank you all for your time, and thank you again, Shrikant. We'll keep
Thanks,
in
Kavya.
touch and we'll keep doing more sessions and learning about more new technologies as we go forward.
Yeah, the space is evolving very fast. Last year, this time probably would have been only talking about chat GPTs. This year, I don't know the count. There's
Yeah.
so much to talk about. So yeah, we'll come back with new exciting topics. Thanks, Kavya, for the opportunity. Thank you, everyone. Have a
Thank
good day.
you.
Bye bye.
Thank you so much.